Welcome to this explainer. Let's just dive right into it today, because what we're looking at is genuinely mind-bending. Imagine walking up to a screen and feeling like you could literally reach out and touch the person standing on the other side. That is the exact promise of Google Beam. It's a jaw-dropping $25,000 teleconferencing system that creates a life-size, incredibly realistic digital presence. It's the kind of tech that makes you stop dead in your tracks. So today, we're going to unpack exactly how this system tricks your brain into seeing genuine 3D depth and what happens when we start introducing artificial intelligence into that exact same space.
To really grasp the sheer impact of this hardware, listen to this reaction from Sean Hollister over at The Verge when he tested it out at Google's Mountain View Labs. He said, "You are definitely three dimensions. Wow, you're totally in this space enclosed by this loop of fabric in front of me. It's a sensory, real enough to touch experience. We aren't talking about a flat, boring video call on a laptop anymore. This is basically a magic trick of genuine 3D space being projected right there in the room with you."
Here is our quick roadmap for today's explainer. First, a real enough to touch presence. Second, how light field technology works. Third, parallax barrier versus active display. Fourth, bringing AI to life. And finally, the future of virtual presence.
All right, part one, a real enough to touch digital presence, crossing the uncanny valley.
So to create this incredible connection, Google Beam relies on a piece of hardware called the HP Dimension, which has this massive 65-inch screen. But the secret sauce isn't just the display itself. You see, you aren't actually looking at a raw video feed of the other person. Instead, the system captures 6 completely distinct real video feeds of the subject. It grabs all that massive data, sends it off to be crunched on Google servers, and what comes back to that 65-inch screen is a highly convincing, high-fidelity digital reproduction. By completely recreating the person in 3D rather than just streaming flat video, the fidelity is so insanely high that it actually crosses the uncanny valley. Your brain just accepts that this digital person is genuinely sharing your physical space. But how does the screen itself pull this off without making you put on a pair of those clunky 3D glasses?
That brings us to Section 2, how light field technology works, the mechanics of the magic.
Okay, the absolute core technology powering this is called an active light field display. To put it as simply as possible, this is a screen that uses a lenticular lens array. What that actually means in practice is that the screen is simultaneously displaying 2 entirely distinct images at the exact same time. It targets one image perfectly for your left eye and one perfectly for your right eye. It's dynamically shifting pixels around behind these lenses to achieve this independent targeting, and that is what gives you that totally natural sense of real depth.
And the visual fidelity required to make this trick work, it is staggering. Because the HP Dimension utilizes a massive 8K screen, it actually has enough pixel density to allocate a full 4K resolution to each of your eyes. That high resolution is absolutely crucial to maintaining the realism of the 3D reproduction. I mean, if it were blurry or pixelated, the illusion would break instantly.
But here is where the whole system gets incredibly smart. It's one thing to project a 3D image to a person who is standing perfectly still, like a statue. But we humans move. We fidget. So Google Beam uses an off-the-shelf camera tracker to dynamically follow your face. Actually, scratch that. It follows your entire physical position in the room. As you walk back and forth or lean side to side, that tracker is constantly adjusting the active display. It ensures the exact right pixels are always reaching the right lenses for your specific viewing angle. That means the 3D perspective remains absolutely perfect no matter where you are standing.
Let's move to Section 3, parallax barrier versus active display, evolving past the Nintendo 3DS.
Now, a lot of us probably remember the glasses-free 3D of the Nintendo 3DS. It was cool, but that device used an older technology called a parallax barrier. A parallax barrier essentially relied on physical slits to block light so each eye saw something different. But it was static. You had to hold your head in exactly the right sweet spot, or the entire image would just blur into a mess. Google Beam's active light field display is a totally different beast. Instead of just blocking light, it's actively changing what's on the screen, routing different pixels behind different lenses dynamically. When you pair that active display with the dynamic camera tracking we just talked about, it is vastly superior. It frees you completely from that rigid sweet spot, allowing for a much more realistic, conversational presence where you can just move naturally. So now that we understand this jaw-dropping hardware, what happens when we change who or what is on the screen?
Section 4, bringing AI to life. Meet Sophie.
Meet Sophie.
She is an AI agent that Google is experimenting with. She's designed not just to be text on a screen, but an actual persona you can walk right up to and talk with. And her capabilities are wild. Because she has access to cameras, she can literally see your surroundings. If you hold up a physical object, say a phone with a MagSafe case, she can identify it. She can even recognize American Sign Language signs like "I love you." On top of that, she can pull up maps and directions and seamlessly converse in multiple languages, like Japanese. It's easy to see the potential applications here. Google imagines this tech being incredibly useful in everyday settings. Picture Sophie greeting you at the front desk of a workplace, assisting customers with directions in retail shops, or even acting as an interactive, lifelike tutor in schools.
Now, we do have to look impartially at the current reality here, too. Sophie is a preview demo, and there are definitely some real limitations right now. Interacting with her can still feel a bit like talking to a standard chatbot. She relies on some pretty rote conversational patterns, she takes these long processing pauses, and she suffers from what developers call model drift. That basically means her accent will sometimes just inexplicably shift right in the middle of a sentence. But the single biggest limitation, Google isn't actually projecting Sophie in 3D yet. Currently, she is still trapped in 2D, just flat on that amazing 3D screen.
Finally, Section 5, the future of virtual presence, expanding the ecosystem.
Right now, Google Beam is a very high-end, highly exclusive piece of hardware, but they aren't keeping it isolated. They're actively working on experimental features to bridge the gap between this premium 3D environment and the standard devices we all use every single day. They're testing a group chat feature that actually integrates 2D laptops and smartphones, using familiar, everyday software like Google Meet and Zoom right into the Beam teleconferencing environment. So, while they aren't committing to a solid release date just yet, the goal is crystal clear. They want to seamlessly blend standard video conferencing with this wild next-generation hardware.
Which really leaves us with this final, completely fascinating question to ponder. We have seen how incredible the 3D presence of a real human is on Google Beam, and we've seen the early, somewhat clunky 2D steps of AI agents like Sophie. But when those two technologies fully merge, when that 3D light field display projects an incredibly smart, responsive AI right into your physical space, will that AI ever truly match the presence of a living, breathing human? Or are we just forever chasing a Star Trek holodeck dream? It is a thrilling frontier to watch, for sure. I hope this explainer helped you understand the incredibly complex mechanics driving all of this forward. Keep learning, and we'll catch you on the next one.